Okay, so for this lesson, we are going to solve radicals. This is the second day of the lesson because on this day, we're going to deal with extraneous solutions. So for this first example, we need to isolate the radical. Notice these problems already have the radical isolated. There's nothing to move. That step should be done for most of your questions already. Now that my radical is isolated, I can do the second step, which is to eliminate it. To eliminate the radical, I have to give them the same exponent as the index. Here my index is 2 because it's the square root. I don't see the index, so it's the invisible 2. The exponent has to equal the index. When I do that, my base, what's inside of the radical, gets to come out. The radical is gone. And on the other side, the same thing happens. Now that I've done the second step, I can do the third step, which is to solve for x. To solve for x, I'm going to add x to both sides. That gives me 2x plus 2 is equal to 3. Now, if I want to get the x by itself, I'm going to subtract the 2 from both sides. That gives me 2x is equal to 1. The last step is going to be to divide by that 2. That gives me x equals 1/2. It is a fraction, but it's fine. I'm just going to check that it works. When you check it, you have to plug it back into the original problem. My original problem had the square root of x plus 2, but instead of the x, we're going to plug in the value that we think is the answer. In this case, it happens to be a 1/2. We're going to put that exactly how you see it on the calculator. So you do the square root of 1 divided by 2 plus 2. It should give you a decimal. That's 1.58. And then we're going to check it on the other side of the equation because we don't know what that is. It's not like last time where it was equal to a number. Now we just have to plug in the x value. And it should equal to 1.58. Because we have a true statement, the solution is not extraneous. My solution is x equals 1/2. That's it. On the second question, the first step is already done. The radical is isolated. I do want to show you what it would look like if it wasn't isolated. If we had x equals square root of 3x minus 2 plus 4, that's when it's not isolated. That's when we see the radical. There's a plus 4 on the outside. We need to move that 4. It'll be x minus 4. That's how we isolate. But this step already has that done for you. Like this problem has already x minus 4 is equal to the square root of 3x minus 2. So it's already has it done for you. You don't have to worry about that, doing that step. Now that it's isolated, I can eliminate the radical where we square both sides. That'll give me 3x minus 2 is equal to x minus 4 squared. I'm going to use the notes on how to square binomials. If you want to watch that video on how to square binomials, you will see how I got x squared minus 8x plus 16 as my answer. This is square binomials. Again, you might have to watch that video in order to see how that happened. But once I do that, I can verify that I got rid of my radical. So I did the second step. Now I can solve. To solve, I'm going to move everything to one side of the equation. Go slow, one step at a time for you. Start by adding 2 to both sides. And then moving the x. That's x squared minus 11x plus 18. Now that I have it like this, I have a quadratic problem, a quadratic equation, which I need to solve for x. So to solve for x, I'm going to find my a, b, and c value. Do the x puzzle. Numbers that add up to an 18, but no, multiply to 18, but add up to negative 11. That's going to be negative 9, negative 2. Put those two answers in parentheses. And then solve for x from there. I'm going to show you how to do this one in case you need to see it, but all you do is add the number to the other side so you get rid of it. So essentially from here to here, we change signs, kind of like when we did factors versus roots. It's the same idea. You just change signs. When they're in parentheses, you change the sign. When you take them out, you do the opposite. Anyways, I have both answers. I have two answers, sorry, and I have to check both of them. So I'm going to start by checking 9. Oops. 4, 9. I'm going to check it on the left side of the equal sign for where it was x minus 4 equal to square root of 3x minus 2. That was my problem. So I'm going to start by checking it on the left side. Left side will be 9 minus 4. And I have to make sure that it's equal to the square root of 3 times 9 minus 2. So basically, I plugged it into this original problem, but instead of the x's, I replaced it with a 9. 9 minus 4 is 5. This would go into the calculator, the square root of 3 parentheses 9 minus 2. The calculator should give me 5 back, so it works. X equals 9 is a solution. And then I check my other answer. We do 2 minus 4 equal to the square root of 3 parentheses 2 minus 2. 2 minus 4 is negative 2. And then the square root of that on the calculator, I think it gave me a 2. These two numbers are not the same. It gives me a false statement, so I have an extraneous solution. That's what an extraneous solution looks like. I did all the work correctly, but my answer does not work. It gives me a false statement. So my extraneous solution is x equals 2. That's my extraneous solution. My actual solution is x equals 9.